I've got too many windows open. Look at all the windows open. Look at all the windows open. Hello. So what I did off stream, one of the main things I did off stream was, I mentioned this before in the last, we had this lock intrinsic, and I'm replacing it with a compare and swap intrinsic that returns a bool, also returns the old value, although I don't tend to use that. And while I'm doing that, I'm looking at like RP malloc, which is apparently translated from a bunch of C macros that I don't know. So I'm trying to replace this intrinsic everywhere else except here. So now we're gonna, I gotta compile the compiler. Who compiles the compiler is my question. Who compiles the compiler? It's such a deep philosophical question. Okay, so we're going to run this on these tests. Okay, that didn't work. Did I just mess something up? Or was this broken? Like, I didn't run this, so I don't actually know. So I've been editing this. We're going to revert that for a second. Dude, what is wrong with Windows, dude? Okay. Now what's going to happen? It's broken. I guess we do not. That's not great. We need test coverage of this. Well, maybe the other things work. Okay, well, I don't want to debug that right now. So that's old. So the module parameters, yeah, there is no pretty print. Oh, maybe there is. It keeps going. Okay, Linux huge. Yeah, there's just no pretty print. So I don't know when that was deleted. Okay, that's also messed up. Let me see though, because that might be. We fixed some stuff. Like there were some a while ago. There were some bounds checks. Memory span mask. Yeah. I think there were some bounds checks that. Although. Yeah, that's just a bitwise and, so that should be fine. All right. Yeah, so this hasn't been updated in a while. We'll see what this says. This test takes a long time to run. Look at all these changes. Modules RP fixed that ARP tests had decayed and was no longer compiling. So maybe, yeah, okay, this is really bad. Oh, it's another cast bounds check. Corrected some casts that violated casts bounds checks, which were broken when RP malloc was checked in, then fixed sometime more recently, which did not work for S64. Let's be more specific than broken. Is anyone here on the beta and has used RP malloc? I bet nobody's using it, right? Because like, or maybe you have to use it really heavily to hit these. Or yeah, 462. Oh, this is in the test program. It's not even in the allocator. Yeah, okay, let's just try that. Yeah, there was a thing where, you know, when we cast from one integer type to another, we check that you're out of bounds or that you're in bounds unless you say no check, right? So if you, and that only matters, right? If you're smaller and going into a bigger numeric range, it's an implicit cast. You don't need to cast it, right? But if you have like a 32-bit number and you know it actually fits in 18 bits, you can cast without the check and the bounds check will tell you that you're correct, right? But when you're doing a sloppy cast like this, because if you're used to programming in C or whatever, you need to document that you may underflow or overflow, right? And that's what this is. Okay, we did it again. I got the wrong one. What the? So size T. Size T is probably, I don't know. We'll keep going. We're just gonna keep putting the no checks. Sloppy cast. Certainly not cowabunga oriented program. I mean, cowabunga oriented programming does not require a cast. Okay. So I think this isn't in the test suite because it takes a long time. Is why. Okay, but this is good enough. So if I go, well, okay, we're going to edit RP malloc from scratch because I don't want to copy it back and lose that cast that I did. Okay, lock compex. Yeah. Okay, so I'm going to do this, by the way, because these should be polymorphic, and it's easier to make them polymorphic now. So we're just going to do this. So we're going to do compare and swap. And we're going to go if success break. And then we're going to copy this pattern like 8 times. Right? So that gets rid of this atomic store. Oh, bro. Oh, the test again. Wait, access violation reading that location. Oh, that's bad. That's before we changed anything. Okay, this is bad. All right, let's not. Maybe we'll put up a bounty for someone to figure out what the fuck happened. But I'm not going to change this like while it's broken. That's just asking for. After these changes, we note that the tests still don't pass. We will post a bounty for anyone who wants to investigate and fix. Any information such as which compiler, even something simple, accelerate the debugging, like in which compiler version this broke, would be helpful. All right. Does casting negative numbers take any extra work? From signed to signed. A little bit, right? Because for unsigned to unsigned, you don't have to check one of the bounds, right? Because you know, like the new range is that it has to be greater than or equal to 0, and the old range is that it has to be greater than or equal to 0. So unsigned to unsigned is like the easy case, right? If the compiler was checked into Git, gig blame could do this automatically. But you know what? I saved a tremendous amount of time on other things from not using Git. So I come out ahead. I don't know what to tell you, pal. All right. So yeah, we're not going to touch that. We're going to make sure the tests pass, which they will, but only because the RP malloc tests are in there. Maybe automatically convert to... No. Bro, are you kidding me? That would take all day. More than all day. It would take like a week. The thing about binary search is it's very fast. So like, even a manual binary search, which is more tedious than an automated one, it just doesn't take that many steps. Right? So it's not that big of a deal. I just put that in the notes because like, I don't want to do it. Am I compiling the compiler now? Not really, but, you know, it's fine. All right. So we're going to actually deprecate this guy. And earlier today, I got rid of that from almost everything except RP malloc. Do we get any lock comp exchanges here? European cores. All right, cool. So fix some RP malloc test issues. RP malloc is still broken. Deprecate lock comp exjug. All right, so I did that. Cleanup, just use, yeah, we did that. Wait, yeah, I did that. Okay. The error message, in you know, I think we have a test for that. Well, we could do a little more, but okay. Okay, what do we do? we go to the error message. Okay, the error message we are talking about, we can reproduce, and then we will make this into a good step, a good test, right? So we're going to go f of let's just do it. I was going to be fancy and pass a type, but that's not. So the typical use case is like I'll have some variables, right? Right, and I'll go f a64. Bro, don't tase me. 32, 16, 8. All right, so this is how you would typically do it. And then we would say, what would we say? We would say ASM and then some instruction that I guess we'll copy from somewhere, like one of the ones that doesn't have an 8-bit variant is what we want, right? So bit operations, right? So here we have bit scan forward, and there is no okay, so return we'll do this. Result is S16 equals -1. All right. So this will fail for 8-bit T. We are checking the quality of the error message when that happens. All right, so we go here, and invalid instruction mnemonic, which is not very helpful. So let's at least put the name in there, and then we'll figure out if there's anything else we can do. Invalid instruction. This is the thing that confused me like last night or whatever. Invalid instruction mnemonic %s whatever. Wait, what? Didn't I just... Oh, I typed it over there. I was like, what? We just happened to have it open right here, because that's where we searched for it. It's a coincidence. What? So when we look up the mnemonic... So the problem is... Yeah, okay. So we have to make this %c, comma, well, okay. If explicit size ASCII, else, I mean, I guess do we always set explicit size ASCII? No. I don't know. There is a case, because we're trying to default to, I don't know. Yeah, we'll just try this. So we're going to put the name here. So we have a variable called name down here. Attempted name. That's not really that much shorter. I wanted a shorter name, like name, and we didn't get it. All right, so explicit size ASCII. All right. BSF.B. Okay. When we do the near matches, if we match up to the dot, then that should be a thing, right? Also, what happened to BSF.Q? BSF dot. Like, why didn't we see BSF.Q? So the match algorithm needs to get better. All right. But when ASM gives the error invalid instruction mnemonic, we now tell you what the mnemonic is that we were attempting to match, which didn't necessarily matter before, since it was obvious from the quoted program text. But now you will want to pay attention to this in case you pick something invalid. For example, if BSF-T resolves to BSF.B on x64, there is no such instruction. Okay, we're just trying to give people hints. All right. You know what? We're going to take the W on that. Like literally just that error message. Better ASM error message. Boom. Q is a 180-degree rotated B. Does return cast, comma, trunc return two values? No, the comma modifier on cast just says, that just says we're tweaking the cast. You can return two values with comma, but that comma is not a two-value comma. That comma is, all right, better closest instruction matching. Okay, so like the fact that it doesn't get BSF.Q is insane to me. Like, how is it move D? How does it think move D is close to B? That doesn't make... Maybe it is BSF.Q, but there's a bug, and it got moved. Where the hell is move D? It's like 5. Let's look at near matches. Where is that? Probably in the same... It's literally right here. So, okay, we make the near matches in when we fail. Near matches. Okay. So here we clear it out. We don't have something for this. Hey, look, I was already complaining about this. Okay. So let's just say actually, let's put this here. If C1 is equal to dot and C2 is equal to dot break, I guess, right? I hate typing in this thing, dude. So yeah, the distance will stop. If we just break, the distance will stop going up. Let's just see what that does to our results. Literally didn't change them at all. Why are we doing an insert at? No. No, this is crap. This is probably buggy. Like, this is probably how we get the move D, right? Wait. Maybe this isn't actually inserting, it's overwriting. No, it's frickin' inserting. Like, this feels wrong. Okay. Here's what we'll do. If match sub 0 is equal to B, and match sub 1 is equal to S, and match sub 2 is equal to F, hopefully I don't segfault on a 2-character instruction. Dude, why is this editor so fucking shitty? After trillions of dollars of investment. Unbelievable. All right. So here we go. Okay. So the match, first match is BSF.W. Okay. So we're going to go. So distance should still be 0. Yes, it is. B, S, F. So now it's still 0. And it should, wait. Oh. We're not breaking out because name doesn't have a suffix. Oh. Wait, what? Do we strip the suffix here? How did we get this? Oh, it's literally just this. Okay. Like, this doesn't have a suffix. So we're actually going to be simpler than this. Oh, dude, what? Yeah, we're just going to... This probably still isn't... There's probably like 5 things wrong with this. Okay. Do you see that this is much better results? It's because we were taking the distance of like the dot and stuff after it and whatever. I mean, there might be other problems, but I'm going to leave it there. We improved the near matches report for invalid mnemonics. We should say opcode instead of mnemonic. Like, come on, man. Mnemonic is a crappy word to say a lot. So that it should be more helpful in more cases. We fixed a bug in the near match. Yeah. I mean, sort of. Like, I don't know. We're not really doing a super sophisticated near match thing. So, like, we should add a little bit more distance. Because if you get a dot and the other one is not done, like it's not a 0, we should, like, add some distance for that. But how much distance do you add? What does he do? What does he do when... Okay, so if we run out here... Oh. Actually... Okay, this is really... This is really what it should be. Okay. Distance plus name.count. Yeah, that's what we wanted. I just need to read the code. All right, yeah, see, these are better matches. BT was winning because it was shorter. right? So now we're getting a distance of 1 per extra length, which, to be honest, probably isn't enough. Let's do at least 2. Three. Like, it is just a heuristic. How many points of distance per letter missing is the right amount? So all this is kind of crap, because if you delete a character in the middle, we're not going to see that. So this is not good. This is not good. Okay, first of all, this is even wrong, because character index is 0 based, right? So if we're at character 2 and name.count is 3, he would also be at character 2, right? So like, that's crap. But yeah, this is worse. Okay, wait. What? Something's going wrong here. Because now our BSFs are not ending up at the top anymore. So we're going to go till we get to the dot, and it's going to be something really stupid. Name.count is 3. Character index is 3? Oh, because it's after. Okay, I was wrong. I heard another song today that had a lot of... Oh, it was the Cranberries song. We could make a whole compilation of songs of people saying I was wrong. All right. So this is actually not good, though, because I like the BSR. BSR is clearly better. And then here, see, this is biased. Let's just put a 3 here for a second. We actually want, I don't think that's going to change the result. Yeah. Let's change these back to 1. Okay, so I don't get it. So there's something else wrong, probably in that insertion sort. And the reason I'm saying that is so BSR, the distance from BSF to BSR, let's look at where that's computed, right? It's just, it's only 1. I see. I thought he was going to maybe take the alphabet distance. Okay, never mind. So then in that case, it probably does make sense to count missing characters as 1. But here's what I don't get. If we crank this up to 3, that should mean the distance of BZ high is more than the distance of BSR, right? Because the distance of BSR should still be 1, right? But the distance of BZ high should be plus 2 more. And yet that makes it win? And then move D fucking shows up again? Like, who are you fucking kidding, right? What the fuck just happened there? I accidentally hit a key that I regretted. What is going... Oh, the times is gone now. All right. Like, what? Like, we're theoretically penalizing you more? So, like, if we crank this up, anyone with a big length should not be in the list at all, right? We should only get the same length. Well, that kind of happened, but then we got RDMSR. That insertion sort is just fucked. Like, so we're going to break before the return, and we're just going to see what the scores look like. Wait, is there an early return? No. Near match is added. Near match scores. Near match scores. Oh, God. Oh, they're U8s. 2, 2, 2, 3, and 34. Explain to me how that makes sense. And what happened to the zeros? Like, let's break here again. Okay. We should have some zeros. Distance is currently 0. Character index 3, name.count 3. Distance is 0, and it's not ending up in the result. So I could either rewrite this or debug it, and I'm just going to rewrite it. Because I don't want to figure out why he thinks this is good. Do we have local array? Yeah. Okay. So here's what we're going to do. We're going to make a struct because fuck this fucking multiple arrays thing. So we've got a near match. It's got whatever the type of this is. ASM, x86, mnemonic, opcode, and then distance. Screw it. Distance. All right. So we're going to have so he's calling that near matches. We're going to call this candidates. Yeah, all right. Local array near match candidates. The way that he wrote this code, it's trying to be very low level code, and you just don't need that for this. It's just Ryan's style, but I do not like that at all. So we are going to make sure the candidates are right. We're not even going to try outputting it yet. We're just going to break and make sure the candidates are good. All right. So we do this, and then we have this, and instead of all this code, we're going to say if candidates.count is less than, we just add it, right? Auto match is candidates.add. match arrow opcode equals this. All right. And match arrow distance equals distance. So we're just filling it up till we have 5. Okay, that's fine. Just fill the array till we have 5 matches or however many. Okay. Else, now we compete with the dudes. Okay, here we go. What I'm going to do is I'm going to say, in addition to candidates, I'm going to write this a little more complicated than, actually, you know what? Let's not even. I was going to put in an optimization. Let's not even do that, dude. Because you could, so we're going to iterate over the array and find anyone who has we're going to find the lowest element. Let's just do this. Yeah. For we're just going to say int lowest or highest distance index is 0, and what is S64 highest distance is candidates 0 dot distance, right? So what we can do later is we can cache the highest distance, even though that's no longer, because we're going to replace this, so it's not even the highest distance in the array anymore after we compute it. But you're guaranteed that if anything is higher than that, it definitely should not go in the array, and that'll early out us for almost all these elements. You don't have to be smart about insertion sorting or anything, right? All right. So for all these, let's just delete all this. If, let's just say, match.distance is greater than highest distance, right? Highest distance index equals I. All right. So now, if distance is less than highest distance, we don't care about ties right now, probably. Because if you're tied with an array full of things that are all the same, well, that doesn't have to be how it is, but we're not going to care about ties right now. I mean, ties at maximum distance, right? So if we're less than the highest distance, then we will just say candidates highest distance index match arrow distance equals distance match arrow opcode equal. I'll just paste this. Let's just paste these two lines. All right. So there we go. Now we're not, so at the end of all this, we probably should sort them as well. So we'll maybe do a little Q sort at the end, but and Q sort in C++ is annoying. All right, wait. Oh, so what's happening is we're no longer, so remember when I said I don't care about the output yet? We're crashing because I'm not initializing the output. But that's fine because I also said we're not going to look at the output yet. We're just going to do this. Wait, that's even the wrong. Let's go down to the bottom. Ignore. All right, so candidates. We have 6. What are our candidates? Okay, we have negative distances. So that's why that was one of the problems. So now we don't want sign distance. So that's obviously happening here. We're amplifying it. Right. So where's my 30? Remember when I put these 30s in? Node check-in, remove the 30. This is like sometimes a good way to validate that you're sane, right? It has to be here, but like I don't understand how this is possible. Unless we're reading beyond name.count. Which we're obviously doing. Oh, well, except here. Okay, well then how are we getting negative distance? We're adding 1. We're adding 30. It has to be this one. So let's do this. I don't know where else we would get a negative distance. So, dude, there were several bugs in this function. Character index 4, name.count 3. Oh. This should probably be greater than or equal to, right? Because and it should probably be down here. Because if we're equal, we're going to iterate and then be greater up here. And that's bad. Because then we're comparing against uninitialized data, right? So it sounds to me like but the greater is just for paranoia purposes. Yeah, okay. Hey, we no longer asserted. Let's look at our candidates. BSFW, BSFD, BSFQ, BSRW, BSRD, and BSRQ. This is again, okay, I've said this a lot lately, right? But like, the results were kind of reasonable. Even the super broken ones were kind of reasonable. And a lot of programmers would just be like, oh, it's complicated, whatever. But it's like, no, there were like 2 or maybe 3 separate bugs in this. We don't even know because maybe more because we deleted that insertion thing, right? Okay, so before we sort, let's just fill out the output, which is near matches. All right. So then we'll actually run, and they just won't be in order. All right. So if I is less than candidates.count, near matches sub I equals Near matches sub I equals candidate. I'm like, I had a brain fart. I dot opcode, right? Else it's this thing. All right. All right, all right, all right. There we go. Those are pretty reasonable. What happens if we just do something totally random like babe? What do we match then? Okay. I mean, each of those match by one letter. There's like not much that's close. We could weight earlier letters more. I don't even know. J, J, K. J, K. Okay. Yeah, there's... Wait, okay. I don't believe there's nothing starting with J, so I think we're still kind of fucked. What's going on here? Oh, but maybe there... J... Oh, I guess it's B. You know, I learned on 6502 where there was a bunch of stuff with B, but there's literally nothing starting with J in the whole tables. All right. Let's pick something. P, let's go P sub K. Like if I thought there was a P sub K. Yeah, we're getting good results. What if I thought there was a P bub K? There we go. We got a bunch of P subs. So that's pretty good. You know, we could keep going, but I think this is all right. Oh, the 30s could be... You're right. The 30s could be making things weird as well. But the J thing was like literally, yeah, there's no J's. All right. So let's get rid of the 30s. Let's get rid of that. We're going to leave that assertion in there. Okay. Great. Now, we don't really need to sort, but we're gonna. And I had like a Don Mitchell sort at some time, but I forgot what it was. And so I just use qsort. And qsort sucks because maybe I can use something. Compare files. Oh, that's... No, we don't want that. I mean, we just want the name. All right, we'll just write it. It's fine. Qsort near matches dot data, right? Near matches dot count, size of near matches dot data 0, and compare near matches. All right. And I always just copy my compare function from another one. All right. So compare near matches. Okay. I think that's right, right? Left of data. Oh, it's not near matches. It's candidates. Duh. Okay. Q sort, argument 4. All right. Yeah, when I changed it to S64, that was a mistake. Frickin' C, dude. All right. Great. I mean, these are all, the distance is 1 for literally all of these, so the sort probably doesn't do anything. Let's do this. If delta, right, return int delta, all right, if they are the same distance, sort alphabetically. See, you can just do things. The reason strcomp has such a fucked up return value is because it's made to be called from sorting functions. So we need to get the names. And I think I just do mnemonic string. We look in the mnemonic string table, right? We look in the mnemonic string table. So there we go. Now it's alphabetical order. The check character index greater than or equal to name account could go to the start of the for loops. Well, let's see. I mean, if you thought that either of these could be 0, no, you don't, like, the thing is, you actually want it to happen before this, right? This is kind of messed up. If you thought either of these could be 0, that would be a thing, but you can't, right? This should sort of be the loop condition, but we want it to happen. Well, I guess... No, I guess you're right. I guess that still works if it's up here, right? Yeah, I think that's still... You're right. You're right. I was thinking about it a little weird, but... Oh? I don't like these results as much. Why is it giving us a different result by doing this? Yeah, you're right. You're right. It's the... That's what I was thinking about. Yeah, the character index... I'm just going to... Yeah. You want it before this. Okay. If name.count or match count could be 0, this would be in the wrong place. But we want it to happen before character index plus plus. And we don't want to jam its ass into the for. So here it is. I don't know, man. It's fine. Yeah. Yeah, if we put it on the other side of that character index plus plus, that's not good. So now the only thing that's really bugging me about this is like the lack of a new line here. So let's go. This is kind of bad. We don't really fprintf to standard error. So we'll think about changing that later. There we go. See how much better that is? Okay. Now it's bad again? What are you talking about? How do you think BT is a better match for BSF than BSR? Why isn't BSF shorter? The answer is because maybe we're sorting in the wrong direction. Yeah, good point. Let's look at that. Dude, I so often sort in the wrong direction, it's not even funny. It's just, yeah, okay. So, where's our frickin' file? We were just in this file. Why is this hard to find? They should like, see, the whole time when Visual Studio went to this fucking flat UI that they've since undone kind of. Like all these icons used to be monochrome because they decided that that was the UI trend of the year that year. And they've at least put color back into them so you can read them. But like the fucking tabs, if you're going to put them in random order like this, like just make the most recent one the brightest, right? And then dimmer, and then dimmer. And so I can look and see what has been used recently. But no, it's just like fucking gray. Like these people have no idea how to do anything. It's so bad. Okay, let's look at this both before and after the Q sort. I'm getting hungry again, dude. Candidates.data, comma 6. Oh my god. Wait, what? Oh, candidates is 1. What? Oh, we're guys. Guys. I hope you spotted the problem. This is like inside the loop still. That may not fix it, but yeah, it's still in the wrong order, but it'll make more sense now. All right, so now candidates has 6 things. BSF 0, BSR 1, and then we'll Q sort. Yeah, we're sorting in the wrong direction. So the reason I get so confused is because if you're going to take a vector between A and B, you do B minus A. Okay? But for Q sort, it's like it's the opposite. And so if you do a lot of math, you're just primed for like the wrong thing. Okay, here we go. I think that's quite nice compared to the old report that sucked. All right. Now we could put in this optimization. But I'm not gonna. We could maintain the highest distance in the table. Now, you know what? And if I mean, we're only comparing it against 6 things, right? Like, a moderately unpredictable branch might be slower. I'm just going to put the note. And if our new item is higher than that, we just discard it without checking. But maybe that branch is slower than iterating over 6 things. I don't know, man. All right, whatever. It's error reporting in ASM. How much do we care about speed? I am erring on the side of not doing this right now because this code was super broken and I just made it work better. So let's not break it again yet. Okay? Okay, great. Let's run the tests. I mean, I doubt that they will be affected by this, but you're replacing the highest distance one, so you'd have to find the 2 highest distance ones. No, because I don't actually care about 100% accuracy in the reject, right? That was my point. If we're higher than the highest distance, we know there's absolutely no way we're in the table, right? If we're equal to or less than the highest distance, we might be in the table, we might not. But it's not worth the extra complexity of being more accurate in that rejection. You know what I'm saying? Like if it were a super expensive operation, then yeah, you would want to be 100% accurate. But this is just not one of those cases. You just have to be wrong in the direction that makes the result correct still, right? What if all the BSFs were on one line in the report? Yeah, maybe. I just want to get feedback from people. There's so many assembly changes that like I'm now in the mode of like, dude, kind of put a lid on it and ship the beta, right? But we've got several more things we got to do. That is a thing that we could do though, right? Like it does feel a little bit wasteful that it's only really 2 mnemonics. I don't know. Okay, we did this. Explicit tests for the new features. I mean, we already have our byte swap test. So maybe we just make a different version of that. That's not the one I was thinking of. Maybe it was. I don't know. Intrinsic. Yeah, well, we have a general intrinsics. Is there an ASM? No. Like what? We literally did a thing that tested. Dude, what? Just give me the... my God. Give me the fucking modified thing. Like, why are they so dumb? Like, why are they so dumb? All right. Intrinsic compare and swap. That's not it. Iteration, bit intrinsics, MISC. Implicit cast. No. Context updating of globals. It might have been a regression test. Maybe it's bit intrinsics. I don't know. No, this we just modified this to fix some things. This is calling in. Let's just see what's in this one. Oh, this is not going to use any assembly. Dude, I wish I knew. Maybe we just didn't check that in as a test because I was like, it's redundant with the other things. You know what? It's fine. We can turn this into our test, right? Oh, we actually wanted this to be a good error message test. So we're going to copy this. And we got to do a little more than we usually do because this is a test intended to fail. So we have to tell the test suite what it's going to say. And all right, let's just go. Oh, wait. It's in the wrong place. It should be there. So, all right. Test fails ASM mnemonic. So it's pretty early in the alphabetic. Test fails ASM mnemonic error messages. And that should fail. And we want to see invalid instruction. We want to see bsf.b, and we want to see bsf.q later on. All right. Let's run those. How do you like them apples? How's everybody doing tonight? How was your Christmas? Did you get a chocolate Easter bunny in your stocking? Is what I want to know. Dude, we hack the Gibson every day here on this channel. I've actually never seen that movie, by the way. I don't know about hacking the Gibson. I just know that it's a thing. So, you know. Okay. ASM error message improvement plus test. Boom. Wonderful. Now. Oh, no, we're doing this one. So this can be turned into a test for the new features. We're going to do this. So we're just testing the question mark T. See, this will fit into all 4 of them. Actually, no, we don't want to fit. We actually want to do this. Okay, you know what? We don't want this test to fail on ARM, right? So we're just going to be like that. This will work because this is a polymorphic function, so we won't try to instantiate the body if we don't call it. So we don't actually have to put the if in here. All right. I64 is this, I32 is this, I16 is this. I mean, we could have it be the top bit, right? That'll be easy. Well, we're not allowed to call print because we've been canceled. Sorry. All right. 5, 4, and 9. That's not right at all. What? Am I smoking crack? How's it going, everybody? Wait, what? Oh. Guys. What is value? Can somebody tell me what's the problem with this function? Does anyone want to suggest maybe what's the problem here? Yeah, you don't, it's not what we're doing. Okay, it's still totally wrong. Oh, because this. Wait. Why? Dude, my brain has been all over the place today. Oh my God. All right. There we go. Look. Look upon ye. I mean, BitScan is kind of a stupid intrinsic, right? Because, like, why couldn't we have gotten the index of the bit or -1, right? But instead it's like the index of the bit +1 or 0. We could just... We could change that, I guess. I don't know. Maybe I'll ask people what they want. But, I mean, it's kind of stupid to get 64 as the answer, right? Like, that's kind of dumb. Why are we doing that? Like, if we have a signed result, just have it be -1, right? The only counter argument to that is that, like, if you want to put it in a condition or a while loop, then it's false if there's no... Yeah, I mean... But comparing against -1 is not really that much extra. I'm going to put that on the to-do. Ask people about bit scan and what they think is good. Because, like, when I made these intrinsics originally, I was like, okay, well, I don't know what I was thinking exactly anymore, but I was like, oh, they've got to just be hyper fast or whatever. But, like, usability is really important. And if somebody wants the hyper fast version and they don't like that there's a little bit of extra code in one of these, they can copy it and, like, make it the way they want, right? That's what we do. So, man, I don't know. Any tips on how to preserve the body for programming? You're 25 and your arms are... If your arms are hurting, then the height between your chair and your desk is bad, or the height between the chair and the floor is bad. Or you're very, very tense. So work on all three of those things. You shouldn't... It's not... So because people had these problems with, like, carpal tunnel and whatever and just various other tendon things, somehow the meme got out there that, like, oh, that's just what happens if you type a lot. No, it isn't, right? If you type a lot in a good environment, you're fine. So take that very seriously, because you don't want to do long-term damage to yourself. Do I have any preference on a keyboard? I mean, I'm using a very custom keyboard right now, and it's all right. The main feature of my current keyboard is it's not made out of plastic, so I don't absorb microplastics into the testes when I use it. Casey made it for me. It was cool. Cool birthday present. Keychron is pretty high pro... Do I have a wrist rest? Yeah. I always have, though, because, like, it just helps a lot. Like, I've used some kind of wrist rest for, like... I don't use one on the laptop because you automatically have one, but for desktop keyboards, decades I've used some kind of wrist rest. Like, it's stupid not to have one, I think. You're plastic maxing. All right, good luck with that. Good luck with that. Can you see the keyboard? It's pretty dark in here, but it's a Keychron Q2, I guess, but it's got ceramic keycaps and a metal enclosure of some kind. So it's pretty dope. And there's no, there's no numeric keypad, right? It's a 10 keyless style, because then your mouse can be closer. Where's the RGB? There is LEDs on it, but because the ceramic caps don't transmit light very much, it's actually bad to use. I don't use it. Okay, so we're going back. These are our tests. So I wanted to test this. We know that works. I wanted to do this, bits size of t, and it's literally the same code. All right, this is going to be G. Should be literally the same answers. Let's put some asserts in here. We should put, do we like not have a big ass comment on the bit scan intrinsics? Wait. BSF.B. Wait, what? Oh, because yeah. There we go. That's why it's good that we printed BSF.B. And we've got our new matching. It's working better. All right, cool. And then the third thing I wanted to do is just integer literals. So, we're just going to hard code this for one size. Right, so H is going to just be S32. And we're just going to go BSF.32. H32. Oops. That's not what it's called. All right. So that's a pretty good test. ASM size annotations. I don't know what you would call that. Great. These are not even blues. They're like something else. Casey sent me a long message where he explained what they were. The deal is, because these are ceramic keycaps, they're heavier, and then especially the spacebar is super heavy. So he put like stiffer switches than you would normally want in there. And it feels pretty good to me. It feels lighter to press than the blues that I usually use because the keys are so heavy. I maybe get extremely rare double bounces, but to be honest, that only happened like once or twice when gaming. I haven't really had it while typing. They're not blues though. Unless there's some kind of like stiff hyper blue. Okay, so let's go to the tutorial that tells people all the things. We've got an apple, we've got a banana. And then instead of documenting the sizes, like, let's just not even... Advanced power users will see that you can do that. Okay. We're going to make use of the hard work done in ASM. We have to interop with the high-level language a little bit. Okay. Apple and banana. Okay. Let's try this, right? We claimed it will error. Let's see if it errors. Yep. Oh. Right, we had these warnings. That was one of the things we wanted to clean up from before, remember? So, matching instructions. This is the actual error, but this is like a warning. All right. This isn't giving us a location. We might have to make these warnings better and then disable them from this example. All right. Okay. Cool. Okay. Allocation and pinning. None of that is changed at all. Great. Addressing. Modes or whatever. Great. Great. It's all good. Vector stuff. All right. Oh, yeah. Okay. So let's try to figure out what's going on with these. This variable could not be used as a register operand because its address gets taken. So we're probably printing it or something. And that's a thing we could document. Yeah. I mean, do I really... If we print count, its address gets taken, which... This is not a really good thing that you want to explain to someone at line 50. the compiler which means which causes the compiler to enforce that count is stored in memory, which means you can't use it as a register. Yes, this is a complicated issue to try to explain so early on, but you are likely to run into this. So let's get it out of the way. Here we just assign to a new variable to print, which has its address taken, and then count is fine. Okay, so I'm gonna do that. So we're still, do we print it again later? Yes. Okay. And then this is going to be the same thing, right? We're printing stuff. I mean, this is kind of dumb at some level, but address gets taken because it is cast to any, which is a data structure that points at count. This causes to enforce that count is stored in memory, which means you can't. Okay. That's a reasonable enough explanation, I guess. Bro, we just keep godding them. All right, there we go. Looks like you don't have AVX512F. Dude, I don't even know what that is. I'm surprised because it's a relatively recent Intel chip, but I don't know. I guess I vaguely heard that they started redisabling some AVX512 stuff, so maybe that's what's going on. I missed the end whatever on count. Thank you. All right. So after all the modules, we'll say how to 900 inline assembly fix warnings due to variables having their address taken, add an explanation about why things have their address taken when you print them by assigning printed variables to temporaries. We did this, and then convert to new ASM size indicators. And then, whoops, the thing is we're going to want to do a little bit more here, because we are not talking about the new features at all, and we can do that. But first we will take the W. I mean, either I don't have AVX512F or our detection code is like wrong. That wouldn't be good. Or, well, no, it's not detection code. It's like, how did we compile? So I guess we don't compile with that on by default, which makes sense. Right? Let's see. Okay, we're literally checking the feature flag. Okay, that's cool. I don't know. I don't know if that's correct. How do I know? How do I detect this? How do I third party know if I have AVX512F? What CPU? Well, we can do it that way. Where is it? Is it in here? Ah, it's so bright. Bro, I can't find it. This doesn't, wait, does this not have CPU? I seem to remember that might be the case. i9, where does it say? Oh yeah, right there. i9 dash 13900KF SIMD support. Wow, it supports SSE. Is it called AVX512F? Dude, you can't Google things anymore. It just doesn't work. Okay, CPU ID. Download now. Now I'm getting cherooted and having my Gibson hacked. Okay, what? What am I? What's even going on? The fuck is this? All right. Let search engines die. Yeah. CPU. AVX2. AVX VNNI. I don't know what VNNI is. But it doesn't even say 512 here, right? Look at all this shit I have to deal with if I made a compiler, right? Look at this. Look at all those. It's just completely horrible. All right, because if this said AVX512F, I would be like, oh my god. But it doesn't say it, so enabling it in BIOS. Well, I'm not. Oh, did they disable it because it's slower? Is it one of those? Okay. This is fine. Polymorphic sizes. early in this, up above, way up above, we discussed tagging instruction mnemonics with explicit sizes like 32, like 8, 32, 128, right? 8 or... Okay, we're just jogging people's memory. Sizes can also be determined by variables from the higher level language, which can help make polymorphic functions terse, among other advantages. Okay, so here's a function that counts bits in an integer, right? And we're just going to copy the pop count. It's copied from modules bit operations. We're going to copy it, but we're going to kill the fallback because we don't care about that in the assembly tutorial. We're going to get rid of that. Dude, I need to replace my frickin'... Dude sent me a more up-to-date thing. We will explicitly specify the 16 as above. Okay, let's go bits here. Okay, so we'll do that. Okay. Or we can just use T if we put a type after question mark, we'll get the size of T in bits. We'll do that instead of making two duplicate functions. Yes, we just redundantly computed result, but we wanted to show both ways of doing it. Okay, of sizing the operation. All right. My pop count. A B S64 equals OX. Good food. No, G is not a hex number. What did we do last time? We did this, and then we did that, right? Because pop count, my pop count is polymorphic, it will work on values of any size for which okay. So A result is my pop count A. B result is my pop count B. Okay. $11 and $38. I guess we believe those. All right. I mean, that's good enough documentation for now, right? Added polymorphic sizes to explain the new feature. Okay, that's pretty good. So there's just one more thing before shipping the beta, and it's fixing this type info thing. I kind of want to take a Pomodoro right now, and then we'll at least look at it, but I might be done for the night. I might want to do that one tomorrow. Like, who knows? Oh, I didn't take all my vitamins today. Hold on. Okay. I was really only missing the magnesium glycinate. So back when in the late 90s, when I was working on my first game, we used to play loud music at the office. And there was one period of like 6 months when a lot of that was like The Offspring, because it's a good way to get like revved up. And then I forget who does this other song, but there was a song that was popular on the radio. I don't know if it's called You Better Take Your Vitamins or whatever, but it's like, it's one of those like, it's not exactly punk because it's, glam punk, but like, he really liked that song. The You Better Take Your Vitamins song. Yeah, dude, we listened to so much Offspring. Add in some zinc. Oh, there's definitely zinc in the multivitamins. It's weird. I took ZMA for a long time, and like, I just didn't feel like it helped me very much. But if I eat a lot of chocolate, I'll get zinc that way. Vitamins. Is it this one? I think so. Let's see. Yeah, it's this one. Okay, you get the idea. He liked that song a lot more than I did, but there you go. Yeah, I think most of the contents of multivitamins probably don't help most people, right? But for me, it's like I'm dialing it in till I find specific ones that help for me. Um, and I've found some combination of stuff that seems to be good. It's probably I don't need 75% of it or more, right? But that's just how it is. Those must have been some interesting programming sessions. I mean, it's how I learned, man. Well, I mean, I also learned in college and before college, but it's how I got industry quality. Yeah, my problem is I don't like weird organs and liver and all this stuff. So like I'm not in that particular segment of like internet health people. Like bone broth? I don't want bone broth. That sounds gross. Liver King. Well, Liver King is certainly discredited, but there's a bunch of people who are like, dude, you gotta eat the spleen. And I'm like, I don't want to eat the spleen. All right. Or like you gotta eat the bull testicles. And I'm like, I'm fine going my whole life not doing that. So you know what I'm saying? Okay, well, this has been really good. Um, we got some good stuff done this stream. It was only a couple hours, but that's great. And we're ready just about to push the button. The only thing preventing me from pushing the button is a bug completely unrelated to the work we've been doing the past couple days or 3 days, however long it's been that I've been working on assembly. So that's great. And sure is a change list, all of which happened since December 23rd. So, yes. All right, let's find someone to raid. Let's find someone to... The raids have been pretty successful lately. I feel like. Sometimes they are not successful. It's like if you're a Viking, sometimes you go out on a raid and like you don't find nothing good, right? That's how it was when I was a Viking. Any recommendations? Boy, there sure is a lot of may contain sexual themes. What's going on there? Last miles. I don't see a last miles. Is that a name?
Work by the human race.
The joy of Gen 2. No, we're not doing that. We're not doing that. We got some Kubernetes. Kubernetes. Chill live feed of a game dev. Still, I don't see. I don't see any refactoring happening there. All right, maybe we'll bail out. Well, maybe. Oh, this could be good. I'm sure you want to see a mobile JRPG engine from scratch. So that's going to be what we get today. Thanks, everyone. And I'll see you later.
This was an amazing